Hi guys, I am Nitin, and in this video I want to talk about a very cool and interesting project that I have been working on. This is called AI in basketball analysis. So before I move forward, I just wanted to show you this demo video which shows how the hardware platform is set up, so you will have a better understanding about the camera views, so that we can talk about some of the limitations which I faced, as well as the way why the algorithms are developed. Okay, so now that you've seen it, let me just go through it. So it is a hardware platform which is set up just below the hoop, and a iPad is attached to it. So whatever video processing that I'm going to do, it is going to be through the iPad's camera view. And interesting thing is this application runs both on device as well as on server side for some advanced analytics, but that is something I'll get to it later on. So first and foremost thing is whenever the player throws a ball, because the camera is set up just below the hoop, it is able to track the player, and the basketball when is sent through the hoop, there is a mesh of net around it, so the hardware platform catches it and then throws it back. It is also a moving platform, I mean a rotating platform. So I'm using byte track for that. And although it is not very straightforward, and whenever the player goes out of the camera view and comes back, byte track tries to assign a new ID to that player because it does not have any idea about the re-identification. But what I've done is I've written a wrapper on top of the byte track. I can call it as a custom tracker. So whenever byte tracker tries to assign a new ID, what I do is at the stage of assigning the ID for the first time, I also take a snapshot of the player's crop image and then compute the embedding vectors using clip model and store it in the tracker state with that ID. So whenever the IDs are changed, I compare the previously stored vectors and then create a mapping between this newly assigned ID by byte tracker and the old ID which was assigned to that player, and make sure that for a given player it does not changes. So byte tracker essentially takes care of all the computation about the player movements and trying to keep the ID as long as the player is visible. But whenever complex scenario occurs, for example if the player overlaps or goes out of the camera view, I am making sure that before byte track can create a new ID, all the stored embedding vectors of the player are utilized so that we can reassign the same IDs which were assigned to a player. And after that I am doing pose estimation. This is very essential so that all the statistics related to player pose and the way player are playing, if they are doing it great or if they are losing on some of the pose, I can generate statistics based on that. So apart from it, there is also interesting use case to make sure the platform works well as per its intended use, that is to return back the ball when the player throws it towards the hoop. So to do that, I have to also detect when the player is throwing the ball. So I'm again utilizing the post data, and once that is done, the hoop will make sure that it is tracking the player throughout the court and then throwing the back ball to them wherever they are located. I am also utilizing the back camera of the iPad to make sure that I can identify whether the shot was actually made or not. Throwing the ball towards the hoop is one thing, but actually counting the number of shots that they made or missed, that is another thing. So I've done that through the back camera. It's a very tricky way. So the back camera does not directly see to the hoop. So there is a mirror placed at 90-degree angle to the back camera so that it looks upward. The view is like downward from bottom of the hoop. So there are some other additional challenges based on that camera view because we do not have any depth information, but I have tried to solve that. And the final feature is the generating bird eye view of the code. This one is also complicated because the entire code is not visible, so I cannot detect individual key points of the code and then do a simple homographic transformation to convert into a bird eye view. So a lot of assumptions are made, as well as some virtual points are plotted onto the image to be able to transform it. I'll show you some of the examples later on. So here is the demo video, and you can see how the detection and player tracking, as well as ID assigning and re-identification, actually works. One more thing I quickly want to add is detecting when a player shoots was very simple. What I have basically done is to compute the angle between the underarms of the player, and whenever their hands are raised, I am detecting that the player is trying to make a shot. The problem is if there are multiple players in the code and all of them put their hands up, the algorithm will be confused which player is actually shooting the ball, so that it can return back ball to them. But if it gets confused between multiple players because they are raising their hands, it becomes difficult to identify that. So I have added an additional logic, and this is more about to counting when a player has made a shot or not. That is, if there are multiple players playing. So I wanted to count which player has shot how many shots. So which one has thrown how many shots actually. So to do that, not only I am using the pose data to detect that they are in the position of making or throwing a ball, but also I'm tracking the ball's position to make sure that the ball is moving in upward direction, and using this combined data to figure out that a, that a player with a specific ID actually have thrown the ball. Here is another demo video. You can see how all of this works. So what I get to know from this post data is the release time when a player acquires a ball. What is the release time between raising their hands and throwing the ball? What is the release angle? So from what location of the court they are throwing it, at what angle they are throwing it, and while they are throwing the ball, what is their lag angle, and what speed they are throwing the ball. So these are some of the insights which I intended to generate from the post data. Finally, it's time to talk about the bird eye view. This was very tricky and also very interesting to implement. So before I move forward and talk about the algorithm, let's first see the camera view and talk about the possible scenarios. So as you can see, this is how a basketball court would look like. On the right, you can see what I intended to generate as a bird eye view. That is the top view of the court. So we can see which player is at what location on the court. Now, if you see this image, the challenge here is because of the placement of the hardware platform, the entire code is not visible. So unless I know all the 4 points of the code, it becomes difficult to transform it into a bird eye view because all the points are not visible. So let's say, for example, I take some point onto this image, this green point you can see, and I want to transform it. So when the bird eye view is generated for the code, this is how it looks like. Now this was not very simple to generate because I have to assume a lot of things. First of all, I have to figure out what is the ground plane in the image, and then what are the two extreme points which are visible in this image, and then the other 2 points are actually behind the iPad camera view. So those are kind of virtual points, so I have to assume their location in a virtual space and then use that information to do the transformation. So you can see in the image, I took a point onto the original image that is denoted by this green point, and then after doing some homographic transformation to generate the bird eye view, what is its location in the transformed image shown by a red dot. So here is another example. So the green dot shows the actual point on the original camera view, and the red dot shows the transformed view. So I'm trying to map the points to show how the player position will be calculated later on. And here is a cool demo video where I'm using the same technique to figure out the player position on the bird eye view, and you will see how it is showing up. All right, so that was all about the basketball analysis. I know I have gone through it in a very generic manner, but this is part of a commercial project, so I cannot talk in details about the implementation of the algorithms. This was just a case study to show you the project progress and all of the cool features that I have implemented. But I am happy to talk about some of the features which may not have talked a lot about. So if you have any doubts or queries, or if you want to just have a more idea about how the solution works, I'm open to have a discussion about it.